Hey, hey, welcome back, everybody. It's a Saturday afternoon, and today we are going to we are going to make a mini PCB, which is a voltage to frequency converter. So 0.8 epsilon. Before we get down into the nitty gritty, off the top of my head, if I was to do a voltage to frequency converter for fun for myself, I would probably do something based on the 555 timer because I understand the 555 pretty well, so it'd probably be a circuit similar to this. But I don't want to use the 555. I want to use fundamental components such as op amps, comparators, transistors, diodes, resistors, capacitors. And so I was looking through the circuit, and I don't have one off. I don't have a frequency to voltage circuit off the top of my head. I was trying to intuit it, and I was like, yeah, I'm reinventing it at this point, and so I just went onto Google and started searching around for voltage to frequency circuits. And of course, I saw a lot of 555 timer stuff. And then I found, okay, so I don't want to do a 555 timer circuit, and I don't want to do a voltage to frequency chip, right? Obviously, if I was designing a voltage to frequency circuit for a product or test equipment or something where I was getting paid, I would do it where I built it around a chip, probably from Analog Devices or from Texas Instruments, probably one of those two. I'm not sure if anybody else is known for their voltage to frequency converter chips. But anyways, yeah, so I'm coming down through, and I'll see stuff like, oh, okay, this is, probably great, but feels like an application note from Analog Devices, right? That's not exactly what I want to do for the very first voltage to frequency circuit. I want to do something that's just classic, right? Like this is a circuit that was designed by someone that loves circuits. And I found one. I think it's, let's see, this guy. So you could see the schematic looks old, and it says a new voltage to frequency. Oh, we're in for a treat, right? So it says a new voltage to frequency converter, and it's got this old schematic. So I'm like, wow, okay. And then you look at the circuit, and you go, okay, yep, somebody, because they're using different companies' parts, right? And they've got, and yeah, so this circuit was designed by somebody who knew what they were doing. You can just look at it and see, yeah, okay, someone knew what they were doing when they designed this one. So I clicked over to the article, 1975. Okay, that's about what we expect, right? Technically, good op-amp circuits, were possible going back to the early 1960s, but then I started looking at the data sheets for these components, right? So this guy, the 1322, has a slew rate of 120 volts per microsecond, and I thought, well, in 1975, that was probably phenomenal. So, yeah, and you can tell by where it's at in the circuit. Right here, as the input guy, where he switches this reset transistor, that slew rate is probably, no, sorry, it's not switching the transistor, but that slew rate is probably a critical performance characteristic of this op amp. So So yeah, so this this circuit right here with these components is probably well worth being the kernel that I base my first voltage to frequency converter around. So that's what we're going to do. We're going to use this circuit right here from this article by some Japanese engineers, 1974 to 75, whatever. We're going to base our first voltage to frequency signal converter mini PCB on this circuit. So how, yeah. All right, we're not going to talk about the theory and stuff. We're just going to get down into the mini PCB design. This one will probably take a little bit longer because we're going to have to do a little bit more massaging. We're going to have to create some library parts for this guy, I think. All right, let's get started. So, engineering change order, repos, mini PCB, ECO base. This is 1009. All right, ECO form. And then let me also pull up the documents, mini PCBs, product catalog. Okay. 0.8 delta current to voltage. So okay. Duplicate this, move a copy, create a copy, put it back here, rename it to epsilon, change these guys. Hey, what's up with that? Paste, replace with this, search within the sheet, and replace all. Yeah, 1000 replacements. Cool. Yeah, that's fine. Can I say ignore error? Can I say ignore this error checking options? Just ignore it for right now, Nolan, yourself. Do it the old-fashioned way. I ignore this the old-fashioned way. Okay. All right. Voltage to frequency. Okay. This is going to be different. And then just trimmers, trim pots. What do they call them? Trim pots over here. Yeah. All right. Fine. Good enough. Just for the fun of it, we'll click the update now. All right, cool. Wait, hang on a second. That number was 08 epsilon 5, 005. Cool. 08E, save. All right, let's go back to here. This is 08E-005. ECO 1009, requested by, let's see if I can see a little better. There, drop down menu, today, DWG, A. Oops, sorry, you can see that. Initial release, statement of risk, justification of change, that's good enough for now. This is ECO 1009. Okay, back over here in Eagle, close that schematic, close that board, come over here, control panel, turn that project off, shrink this. We need to create a new project up here in signal converters. New project. This is 08 epsilon. We come back down into here, instrumentation. No, that was not instrumentation. This was edit description. This was current to voltage. Okay. Yeah. Yeah, that's fine. All right, now here we want to copy. Why is this blank? No, like why is that blank? Oh, maybe I just have every layer hidden. Let me go and say all, show me all. Yeah, that was it, all apply. All right, cool. All right, nice. Save, now close. That'll scare me less. All right. Yeah, there we go. Do I want it on this size board? So let's see. We're going to have to use, we're going to, I think what I want to do, this is a comparator and these guys are op amps. So I probably want to separate them so you could pick different value components. This guy down here, the LM301, we can probably get a dual in this, right? So this is just a single. Okay. So 1 and 5 as balance pins. That's pretty common, huh? As a common op amp. So this was probably a common op amp pinout, to be honest. Yeah. So a single, and a single comparator. Yeah. So should I use this 50 by 100? Or should I go down to 50 by 50? I need to put 3. We're going to do the 50 by 100. So that way it'll be sure to fit. So we come here and we say copy. Go up to epsilon. Say select folder. Rename. 08 epsilon. Drop down. Rename. Epsilon. Rename. Epsilon. Sure, we'll do this now since it wants to already. Yeah, but it stays there. And this one goes E, all occurrences. Okay, bam. 2 replacements made. Save. Come over to here. This is the 9th. No, this is the 10th. I didn't do anything yesterday. I was supposed to do this. I just relaxed. Huh. Okay. All right. Save. Close. Whatever. This guy we'll keep that panel. This guy can just straight up delete. Delete. Yeah, delete that. All right. Hey, hang on a second. This. Make that the active project. Okay, cool. All right, now go into the schematic. And let's edit the properties of this right away. Signal converter. Op amp. And op amp and comparator circuit. Cool. All right. Single supply trimmers. Should I do dual on this guy? Dual supply. 1009. A and voltage to frequency. Okay. All right. And we're going to delete a lot of this just straight off the bat. Well, we'll hang on to the voltage reference thing. A lot of that stuff right there is gone. And this thing, we'll clean that up like that. Voltage reference, whatever. Okay. All right. Now, let's see what I got in the way of op amps. Not much. Relatively new library over here. So op amp dual quad, op amp single surface mount. I don't want to do the this guy's through hole. So op amp single. So we go into the library. Okay. Library. Yeah. Okay. Let's see. Okay. So new. It's dip. That guy. Rename. PhD. Connect. Now, this is where we go back to that data sheet. And I'm pretty sure this is standard. So 1 gets balance, but I don't have a balance symbol. So I need to copy, paste this guy. Copy. Yeah. Really, because of this guy, I can't, won't let me add 2 more pins. Add. Power. Really? I have to create a new delete. Yeah. Okay, cool. Go up to the component. This guy, I can copy this, right? With balance. With. Yeah. Okay. Yes. Op amp. pin. No connect 1. Want pins 1. I don't want it to look like that though. Want the air? Do I though? I think I do. I probably do actually. Maybe not. Okay. There and there. Okay. Prefix U on. This guy gets A. This guy gets power. This guy gets balance 1. Compensation, balance. No, there's 2 compensations. Ah, fuck. So, cancel. Balance compensation, compensation, balance. I don't know if this is good, but you know, move group. We'll put this stuff up here. Same. Okay. It's probably horrible. Okay. Okay. New dual inline package 08 connect. So pin 1 gets balance compensation. Connect. Pin 2 gets the input negative. Pin 3 gets input positive. Pin 4 gets V minus. Pin 5 gets balance. Pin 6 gets output. Pin 7 gets V plus. And pin 8 gets compensation. Okay. Save. Rename. THT. I should say, that's fine. Okay. All right, that's that guy should be good. Let's place it. Okay. Op amp single with balance. Yeah. Okay. Let's change. I don't like the way that looks. Kind of like just the pin name. Not that. Op amp single with balance. Okay. Yeah. 1 gets balance compensation. So we'll do the pin 8. Balance gets 5. This gets 8. Yep. Okay. Save. You'll just have to have the data sheet. Library, update all. That's U1 pin 1, U1 pin 5, U1 pin 8. You know what I could do? I could go into here, edit symbol, grab this guy, drop it down 1 click, change this to info. I think it's info. Or no, pin name. We'll make it pin name. Yep. Two ends. There, we'll do it that way. Name, pin name. We'll change this layer to be the info layer. Apply, okay. Save. Now we'll go back up here to the op amp single with balance. Now we have these pin name infos here. Okay, drag that up to there, up to there, cool. Now attributes and new pin name. Say okay. I don't know if this is going to work. I don't think this is going to work. Update all. Okay, cancel. Hey, cancel. Move. Give me the parameters. This guy. Nope. 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 Good idea. Doesn't work. We'll just have to do the put that in the pin map table. It'll be fine. Did all, and I didn't hit save, did I? I did. Okay, cool. Let's see. So, all right, that's fine. So that's U1. That's that guy. I think the other op amp is going to be exactly the same. So this is going to have 3. It's going to have 2 op amps, 1 comparator. So we'll make a little bit more space up here. This guy's going to get, the schematic may get too busy for this sheet. You have to go to a larger size, just with the power section alone. Now, I don't have my larger sheets ready. So if I go invoke, hey, that's right, schematic. Really, I didn't set those guys in it. Cancel. Okay. Let's, library, components, schematic. This guy. Can I set a symbol? Schematic A. Continued? Nah. Do Bravo. What? I didn't set that one up. Okay. Cancel. Wrong thing to do. I shouldn't have opened it. I should just come down here. Open that one again. Oh wait, symbols I couldn't copy out. I think I do have to open it. Yeah. Okay. Whoop. All right, here we go. All right. Schematic B cover. Yep. Okay, so this will be larger. Copy. Yeah, we'll just copy everything. Copy group. Let's jump over to, we have to go back to the other library now. Here. All right, give me a new, this is going to be a schematic B. Horizontal cover. Paste. Delete this, delete this, delete this, this. All right, and I'm actually going to delete this table here. I'm also going to delete this table here. Hey, I should show everything. All apply. Okay. All right, cool. I'm going to delete this table here. Delete group. I can leave that. That's not. It's a different whatever. I'll delete it all. Yeah, fine. Okay. Delete group. Cool. Save. Okay. Save. Go into A. Copy. Well, make sure everything is shown. All apply. Okay. Copy. Group. Millimeters. Okay. Copy the group and hey, copy group. Copy group. Schematic. Bravo. Paste. Okay. There we go. Let's go back to the other one. A. Copy group. This guy. Copy group. Schematic. Bravo. Horizontal. Paste. Okay. Should I move that? It's been bugging me. I have it wide so that I could spell out draft, but we decided since I did that to make it where I don't use, I just put an X in front of it. Yeah, group. It's probably good enough, right? I go to 1 millimeter grid, and it's on the half, and it's on the full, so I probably should move it. So it's yeah, and go back and 0.5, and then move it out 1 click. There. Okay. And then the drawing name, should probably try and center that. So if I just draw a line, like from here to, where do I think centered? Here. Copy this guy, move it back to there. So center is actually move this guy. That's center. Now, do I want it like that, or should I just line it up over here? Yeah, I think I'm going to do this. I think we're going to do properties, top left. Apply, okay. Move this guy back to here. It's one too many clicks off, isn't it? That's 2 clicks. So that's 1, 2, second click. And that's fine. Okay, cool. All right, close, close, close. Yeah. Okay. So now copy this group. Okay. Copy group. Go back to the A. Paste. And this. Oh, wait, why did I get that? Yeah. Didn't get the revision in that. Undo. Go back to the Bravo. Copy group this guy. There we go. Copy group. Now go to the A. Paste. Okay. Now come over here, hit delete. I got that horizontal, so I can delete. I can delete and delete. And we'll move delete, move this guy, move group. Oh, move the whole thing. Move group. There. Down 1 click. There. Yes. Save. Okay. So now our drawing nomenclature or number can be longer. Not that we're going to make it longer. And the revision doesn't look bizarrely large. Okay, save, and that's the A sheet, right? So we'll, I need to, hang on, I need to copy this off the A. All right, grab this. Copy group, and B, continue, paste. Okay. Okay. All right. Yeah, we'll put the schematic on this guy. So come down to schematic here. I want to add a new. So schematic Bravo H escape, save. Nice. Nice. That's good. Okay. They're both cover sheets, but it's okay. We'll stick to one sheet for a while. No footprint. So now, back here, library, update all. That cleans up. Okay. I like that a little better than center aligned, I think. And I can right click and say invoke. And I have the B option. And I can invoke that guy, save that, delete this, move this guy back down to the origin. And all my parameters are still the same because it's the same component. And we got plenty of space to spread the circuit out. So now we need to invoke and pick a bigger one. So I thought I had some large ones, 5 by 4, 4 by 5. That's probably, is it height width? No, that's height. So I need the 5, but actually I should probably just go in and make another one right now. Library, component, this is miniPCB. I think we'll do 5-pin, right? I don't need 7-pin on this guy. I don't think I want a 7-pin. Right? Let's do the 7-pin. We'll do the 7-pin still. But yeah, so this large guy right here, this guy, we're going to copy this over to the 7-pin. So actually, if I right click down here and edit symbol, this is the miniPCB 7x3, so we just need to add it. So miniPCB 7-pin. Seven by 3. Should probably do like 7 by 5. Okay. Escape. Save. Update all. Invoke 7 by 3. Yeah, need the 7 by, probably do bigger than 7. Should probably do like, 10. Nine. Do a 9 by 5. 9 by 5. Okay, so back in the library, edit symbol, copy everything. This guy, copy group, symbol, miniPCB 9x5 inch. Yeah. Paste. Okay, so now this guy gets stretched 2 inches. So we change the grid to 2. Say move group. This whole thing right here. Move group. Okay, that's where it is. Go up to there. And that's 7, so we need to take this out 2 inches. All right, so move group 2 inches. And then this guy needs to be moved, if I want to keep it, 1 inch up and over. Yep. And back on point 1 and save here in miniPCB. And we'll drop that guy on here too. So miniPCB 9 by 5 inch. Okay, save. Go back to here. Library, update all. Okay, so we can delete this guy. Invoke. Down to the 9 by 5. Okay. All right, cool. All right, now delete this guy. Move this down to, I don't know, there. Yeah, looks good. Okay, now move this, move group to there. Cool. Now we can move the whole thing so it's a little more centered. Move group. How's that look? Leave room for the pinout table. We can put the pinout table there. Oh, I have good feelings about it. Okay. So let's place another one of these op amps. So op amp single. Op amp single with balance. And we'll put it down here. This guy, and then we'll just set these up here since I don't have a plan for them at the moment. Okay, now the comparator. All right, so this is a high-speed differential comparator. Hey, did I just close that? Oh, man. LM306. Oh, 360. Yeah, LM360. 361. Yeah, let's see what we got here. Datasheet, PDF. What? It's a lot of pens. No. No. Very high speed differential input complementary TTL output. Very high speed. What's a very high speed? Bias currents. Let's see. Propagation delay of nanoseconds. So typical. So min, typical, max, min, typical, max. So typical 14, max 20 nanoseconds. Yeah. So 20 nanoseconds and you're very high speed. Why does it say 140? Where do they get 140? Ensured high speed 20 nanosecond. Well, why do they talk about 140 nanosecond? That's crazy. Anyways, PDIP 8. So 306. I think they did a typo way back when. Instead of 360, it was 306. No, probably not. They probably just don't make that part anymore. Okay. What's up with strobe? A low-level input at either strobe causes the output to remain high regardless of the differential input when both strobe inputs are either open or at a high logic level. Output voltage is controlled by the differential input voltage. The circuit will operate with a negative supply voltage between -3 and -12, with little difference in performance. The LM306 is characterized for operation from here to here. Wow, good. Although, from 0, so that is not very cold, guys. It's not very cold. So this is not suitable for outdoors. Yeah, set 1979 to 91. Yeah, so this is an old part. Ugh. Okay. So we're going to put the strobe on, but we're going to connect the strobe to ground. Hmm. Hmm. I don't know. Let's go back to the comparators. It's just a single Single differential comparator with push-pull outputs. Low voltage, open collector. Push-pull. Needs the push-pull output. So no connect, ground, output enable, power, out 1, out 2. Out negative, out plus. Okay, we'll do the out negative, out plus because we're doing the 7-pin. So we'll make this part differential comparator. I don't want a differential comparator. Loading output comparator. LM311. Probably good enough, right? We'll design around this guy. That's it. Okay. Good circuits here, by the way. All right. All right, this is what we're doing. For the single supply, we just connect the negative to ground, right? Yeah, 1 and 4 to ground. Yeah, so 1 and 4 go to ground together. Okay. Yeah. All right. And Single with balance. Okay. -1, -5, -6. Yeah. New. Dip. Dill. Yeah. Dill on package. Rename. Connect. 1 is, yeah. -1 is 1. 2 is the input positive. 3 is the input negative. 4 is power minus. 5 is balance. 5 is 5. 6 is 6. 7 is the output. And 8 is power. Okay. Save. Prefix U on save. Okay. Attributes. Did I do an attribute? I don't think I did attribute. Okay, cancel. Save. All right, now we go back to here. We can set the comparator. So it's going to be comparator. Comparator single balanced. Okay. Move these guys right here. Move group. We'll put them near stuff. Move this guy. Move those. Move group. Move group. Good enough. Size of that is not the same. Huh. Should probably go in there and make that the same. Edit. How big is this? Edit symbol. Properties. 0.07 inches. All right. Go back into comparator. Back into edit symbol. Size. Save. Yeah, that should be it. All right, cool. Library, update all. Yeah. Okay, there it is. Okay, cool. Move this guy's up here. Move group. And move this guy back to here. Okay, like this. Move group. Dot, 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 dot. Okay. Move and move group. Dot, 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 dot. To there. Yeah, we'll leave that fine right now. Move group. There. Drag it straight. Probably there is fine. Okay. Okay. Save. No, delete this right here. Save. Okay. Need a pull-up resistor. Okay. Okay. All right, let's go back and look at our circuit. So we got that part in the library, that part in the library, that part in the library. We're going to use a so 2N4274 data sheet. This was a big guy, huh? So it's a NPN. 30-volt maximum collector emitter voltage. Only 12. Not that high. 400 megahertz. Collector capacitance. That's really low. What is the how does that guy compare? Collector capacitance. Probably much higher. Yeah. 4 pico. Sounds similar. I want to say that's the collector capacitance. Hmm. Uh, we're going to go ahead and stay with our current NPN transistor because I think it'll work. Yeah. 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 We'll if it doesn't work, we'll figure that out in the prototype stage and the testing, and we'll swap it there. But for the prototype, we'll just keep our normal NPN. This guy is not the one I wanted to use in the bias. That's this other guy. Do I use I can hit delete on this one and then just re-invoke it. Okay, and then grab this here, move this group a little bit. Hey, rah 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 rah. Move group down to here. Something, right? Something. Okay. Do I want to do that? Let me see about this. Okay, so I'm going to be doing this from a single supply. Voltage gain of the comparator. Okay. T1 is a function of those two voltages, the collector emitter and VR. What is VR again? I want to say this is all single supply. Yeah, there's the negative. So all these ground points are going to be coming off of our reference voltage. So yeah, okay. So we'll put this op amp on. So op amp single with balance. Or do I do a dual? Should I do a dual and have it buffer the output? No. Because then you'd have to have a really high speed op amp for that. No. We're just going to do the single. We'll do a dual package though, just because people are going to have it available. That guy goes there. This guy will go anywhere. And invoke this guy. set them up here. I'll figure that out. Okay. So I got to figure out what I want to do with him. Spare op amp. Okay. I think we're ready to start capturing the circuit. So this guy creates our ground reference, basically, this guy. And he's needed at this point here. Those guys, that one. It's basically going to be 2.5 volt. I can run the other guys from 5, right? Okay, should be fine. All right. Okay. Resistor to ground. Up there. Actually, it's to our reference. Then the NPN. Transistor. BJT. NPN. This one. Yeah. Okay. Rotate. Okay. Back it off. 2 clicks. We'll put a cap down here. Copy. Cap. Okay. The base of this guy gets driven by this resistor cap. Yeah. I don't think that moved, did it? Eh. Okay. Just up there. Hang on a second. Okay. Nolan. There we go. 15 picofarad to ground. I just No, you're not going to tell me the pin, huh? It's got to be pin 8, bandwidth control. 20 picofarad stabilizing capacitor. So that's pin 8. But we're not using that part, so we don't have to worry about that. By the way, I went on eBay and I found somebody selling 4 of these. They say new in box, and I was like, okay, I'll buy them. So I bought 4. So not today, but eventually, I really want to see if I can acquire the original parts for this guy from what this engineer was looking at back in 1974, and then maybe make a board. And I want to see if I can duplicate. I think it'd be fun to duplicate this here in my workshop, and experience what this engineer experienced that was so enjoyable that they went ahead and took the time to do this nice little write-up. So, yeah. Let's see. Okay, so going back to here. So this guy's really just creating the reference voltage for that. No? So it takes that guy, trims it down. Oh, yeah. Hmm. Okay. So this reference voltage is going to be the ground. One of these guys needs to be really big. We're going to put a third. There's a lot of capacitance on this right here. To there. We will put a I want a V divided by 2 or VREF. So cancel. When you go into the library, I'm going to create a VREF. Okay. Copy. Oh, well. What symbol is this? V plus symbol. Copy group. Go create a new symbol. Call it VREF. Okay. Yeah, let's create a new one. Paste. Put it right there. Okay. Go back to here. We'll say VREF. VREF. Okay. Create a new device. VREF. Yeah. That's what we want to do. This guy. And VREF. Perfect. All right, place that there and prefix. I think it should be fine. Back here, we vref. Like that. Yeah. Save. Connect or whatever. And like that. Okay, cool. And then this should automatically now have the name. What? Why is it connecting it to plus V? There it is. Apply. Okay. Save. That may mess up circuits where I have a net called vref. I have to be careful of that. Yeesh. Probably a bad idea, Nolan. Yeah. With great care and attention to detail, I shall proceed. Yeah. Okay. All right. Let's see here. Library, update all. Now, let's see what name this is again. Why don't we do that? Yeah. Now, if I copy, I can put this guy up here like that. And not that far. Right. They want that guy with a resistor on vref. Doesn't that just add like noise? Isn't that a noise source? Save. This vref is like substituting for ground because it's supposed to be half of plus V plus. So, yeah. And then, well, 15 pico we don't need. That guy we don't need. We do need a pull-up resistor though on that output. And if this guy's not driving it, then I don't know if it'll still work. The pull-up resistor will have to drive it. No, this might not. Well, we'll try. Okay, so that right there. Wire. Okay. Okay. This gets plus V. V plus, that is. That's there. Set that down. Okay. It's a schematic. Okay. You know what? Just for fun, we're going to put this guy buffering the output. We'll put a buffered output on pin 7. Right? That sounds good. I'd buy that. That way we can see, oh, see, it's not fast enough. The high speed whatever is much better. Or not. And the, yep, like that. Okay. Here, though, let's do it like this. We'll delete, mirror, this, rotate, here, here, like that. Here, grab this, move it down to here, click, click, click. Hey, wrong way, Nolan, wrong way. Move this guy here, there, here, off one click, up to there. Yeah. So if it's low, this will be low. If it's high, pulled up to high, this will be high. Now, got it backwards. I got it backwards. All that works, just get it backwards. Okay, that's better. Now that will follow it like a comparator. Hopefully that being on the same die as the voltage reference doesn't introduce too much noise back onto the reference voltage. But even if it did, this should filter it out. Just, yeah, should be fine. VREF, okay. I'll get that resistor. R3, R4. Okay, let's see here. Rah. So that's ground. For us, it's ground. Okay. Move this guy. Okay, we send it to the plus. And then that guy goes to ground. So we'll leave that balance on like that. It'll be fine. Move this guy, copy, grab it, rotate, drag it down. R1 with a pot to VREF. 200 ohm. And they put a pot. Yeah. Hmm. Hell yeah. Move group to there. Pop, pop, move this guy. Copy. Bref. No, that gets ground. This guy gets bref. Okay. Copy. Hey. Oops. Huh. Did this wrong. Is that it? No. That's not it at all. That's not it at all. Okay. Clockwise will increase. We'll do it like that. Okay. Okay. Hmm. How's my microphone doing? Looks like it's doing good. Not talking a lot, so that doesn't matter. We'll put this guy as the reference input. Hell yeah. Move group. Like there, yeah, that should be good. Okay. Should I really squeeze it all the way over? I don't know. Probably not. Probably should drag this guy to the bottom and kind of shrink it. What other options did I have on this guy? 4x5, way too small. Right, yeah. Maybe a 6x5. Hmm. geometry. Looks good. Okay, so cancel. Hang on a second. Yeah, okay. Edit symbol, copy, group, always, copy group, new. Okay, 6 by 7. Yeah, paste here. All right, 1 inch. Okay, so this is move this guy up 1 inch. No, 2 inches. 1, 2, and move this guy 3 inches. 3, and then 1.5. Move this guy 1 click there, 1 inch up. Save. Okay. Go back over to here. miniPCB 7 pin and miniPCB. Save. Library update all. Invoke. To there. Save. Backup. Hey, hey, hey. That's pretty close. Yeah, that's right. Drag it down. Perfect. Okay, cool. Okay, so that's our VREF. The op amps kind of line up a little bit. Move group down to here. Put that there. Here to here. Here to here. 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 Save. Move this guy here. Move group. Back to here. Here. Here to here. Move group. Bring it back 2 clicks. Say alright. Okay. These guys, we'll go with that one. These guys will go with this one. That one. Okay, so we need to finish this up here. That looks good. That looks good. Sure. We need to put in some pin map tables. Nice. Probably put the op amp power supply stuff down here. Like 1, 2, 3, 4. Something like that. As opposed to across the top. You know what I'm going to do? I'm going to put a dash in front of that PWR. Here we go. Schematic, power, yep, name. No, not that one. Do it in each one, don't I? Oops. Op amp dual. Name on this guy says dash power. Save. Op amp quad. So it's dash power. Op amp single. Not dot. We're going to do dash. Dash power. Dash power. Let's go to the comparator. Dash power. Yeah, there you go. U2 power, U3 power, U4 power, U3A, U2A, U4B, U4A. Okay. Okay. well, this guy took a little bit longer because of all the library editing. We're not done yet, but I think I'm going to go find something to eat for lunch. Otherwise, dinner's going to be pretty late. So, yeah. So anyways, we're just chipping away. Thanks for hanging out. All right, guys. See y'all in a little bit.